The user and developer of abstract data types focus on different aspects of data types. Outline two aspects of data types. The focus of the user, consideration. Okay. User one focuses on what action or operation can be done. Example, etc. And next thing would be focuses on the actual value or data that is manipulated, that's stored. Yes, that's two there. Yeah, what you can do and the values that are there. The developer focuses on how to implement the data type, and what else the developer will focus on? The developer will focus on how to efficiently write and execute the function necessary. Okay, cool. Yeah, something like that, basically. When you're creating an abstract data type, you're basically creating a way to represent data. So it's either a stack or a queue or a linked list or whatnot. Those are ways of representing data and manipulating it. So the aspects of the data types that you're looking for would be the aspects of what would be the aspects of a stack, aspects of a queue, aspects of a linked list. So when a user comes to use a program and they tell you, okay, this program uses a queue, then the user will be like, okay, cool. That means I could push and pop, meaning I have options to store data or remove data, and I also need to know what numbers are using to push and pop or put in the queue and I'm kind of thing, right? You understand? Right. While the developer is worried about what's going on in the background. Alright, describe the structure of Right. Describe the structure of a stack and QADTs. This one kinda weird, but a stack is last in, first out, LIFO, first out, last LIFO, and or you could say yeah, that's basically it. Because you might want to start to talk about top and all them kind of things, but it's really just 2 marks. So you're basically looking for LIFO and FIFO. First in, out. Anything that explains that, it should be okay. If you talk about, things are added and removed from the top and bottom, that's okay. You wouldn't lose marks with. But once you explain the concept of how they work, that's what it is. Alright, right. One real life example of a stack. I put plates. I can't find a way to explain stacks without saying the word stack. So stack of a pile, boy. You will be like a line in a bank. Line at a bank teller. Anywhere that there's a line, it should be okay. Alright, a stack and a queue can be implemented using an array or linked list. State the reasons why an array may be replaced by a linked list to improve program efficiency. We will say that a linked list uses only the memory that, not only the memory uses linked list, only uses memory that is needed. Only uses memory that is needed or adding and deleting or removing value from a linked list or leaves unused space or some kind of thing like that. Alright, that should be good there. Let's see what else they have for us. The methods for queue and stack ADTs are listed in table 1 and table 2 below. The positions at which values are added and removed are the standard positions expected with queue and stack operation. Okay, so they give us all of the things that we can use. Oh, how nice of them. Oh, nice this time. They tell you exactly what you could use in the custom. Alright, so a palindrome is a word that reads the same backward as well as forward. For example, Madam Kayak level race car is a palindrome. Like race, not supposed to be race space car. Whatever. Use the following guidelines to write an algorithm that represents the body function to test if a word is a palindrome. Input algorithm is a queue named Q1 to which a word to be tested has been loaded, such that the first letter of the word is at the front of the queue. Okay. The solution should use another queue called Q2 as well as a stack or stack 1. Solution can include simple variables such as character, but should use no other aggregate data. Oh, big words there, boys. CXC, aggregate data. Let's go. So we have a queue. Let's say the queue has Bob. Bob is a palindrome, and we want to check to see if this word is a palindrome. So we are going to dequeue these things and put it into a stack. There'll be Bob. They say we have to use the queue. Okay, the solution should use another queue, Q2, and as well as a stack or stack 1. So you have to use a queue and a stack to figure this thing out. Okay, so we pushing, we could DQ, and we could, why we have to use a second queue for, I guess? Oh, I guess, okay, you basically have to take whatever inside the queue, put it inside the stack, and put it inside the queue, and then compare each one. Compare the top with the front, and then that one, and then both of them, all of them should be the same. All right, yeah. So we have to fill the two other data structures. So let's start with a while loop. Let's see that we have is empty available. Yeah. While, let me see how they implement this one. Tab is empty with nothing. While is empty for Q1. Okay, we had to put it down. They didn't tell us that it's in our structure. Why are they doing it? Okay, so while is empty Q1 is not equal to 1. So while Q1 is not empty, we will throw out the value. So we had to put it in like a character. So create a character. Character is equal to character is equal to DQ1. And then we're going to take this character and push into stack 1 the character. And then we're going to NQ into Q2 the character. And this while we're going to go on for however long, depending on the value. So we're filling up the stack and the queue. Right, yes. So we're filling up the stack and the queue, and now we have to do a comparison. So the comparison is going to be now, while, because we're comparing both of them, we had to check to see if both of them get empty. Alright, so while is empty, Q2 is not equal to 1, and is empty, stack 1, yeah. While is empty, stack 1 is not equal to 1. Alright, so while both of them not empty, we have to compare. So we're going to say if the value that is DQ, if Q from Q2 is equal to stack 1, and then you will see true is equal to 1, T is equal to 1. True. The value that DQ, the value by pop, if they equal, you say T is equal to 1, L T is equal to 0. No, we can't put T is equal to, because then if the two letters end up matching, we can't do that. If they match each other, you say true is equal to 1. Oh no, okay, we could leave it as true is equal to 1, because as long as true is equal to 1, we know it is true. So we had to set T is equal to 0 at the start. So T is equal to 0. Right, so if it goes through the whole while loop and the T never and the T stays at 0 all the time, no, that wouldn't work out. Because let's say you have a word, if any of the words end up matching, it will put it as true. T could be equal to 1 if you have a word like, I don't know, if you have two O's at the end and they match the two O's, they will say, yeah, well, it was true because we matched it. So we had to come up with a condition that will alright, so we had to put our next and here. Wait, hold on. If both of them are the same size, we do have to check to see if both of them empty, because both of them are the same size. So I could take out this and, okay, there's some high level stuff going on here. So once the is empty is not true, and then we could say and true is not equal to 1. Do this loop on the moment true becomes 1, the while loop will stop. No, that wouldn't work either. Alright, I'll replace it. If they're not equal to each other, we set it true as 1. If they're not equal to each other, we set it at 0. Okay, cool. Okay, alright, so this will be the solution. If you go through this whole loop and you check to see well, while is empty, meaning that the queue still has letters in it, and true is not equal to 1, I mean true gets set to 0. I should just set true to 0. Let me say, and true is not equal to 1. No, true not equal to 1. That's correct. Right. True not equal to 1. Compare the two of them by popping them and comparing them. And if they're not equal to each other, then set true equal to 0. Other than that, keep looping. True will stay at 1 all the time. And then now you'll come down here and you'll say if T is equal to 1, printf palindrome, else printf not palindrome. I think that's it then. Any colons, barren, like barren with semicolon. Did you die or did you have something similar to
it? It was alright.
Yo, it's 9 marks, so you probably could get like a 7 or 8. Barren. Let me see what the examiners report. I think I have the answers to this paper. Alright, yes. Alright, so they pop it into, they put the value into a character, they check the character, right, yeah. True, right, if oh no. Okay, so this here is supposed to be true is equal to 1. I'm gonna say here. While it is empty and true is equal to 1, meaning you're guilty until proven innocent. Yeah, you check true, check both of them, make sure they work, and yeah, alright, good. Yeah, that's it. Next, using a suitable diagram, show the end result of an initially empty linked list after all of the following operations are executed in the order given. Note that new nodes are inserted at the beginning of the list. The end result, the one, okay, so we're going 40, 20, 40. No, 40, 20, delete 40. So 40 goes in first, 20 goes in after. Delete 40 will be gone. Insert 15 comes in front, and then is empty. What is empty? Why is empty just come there just on the result of is empty? No idea what happened. Why they put the is empty at the end there? But anyhow, this is what happened at the end. This is basically ta-da! Pretty much. I don't know why this is empty is at the bottom here. I'm not too sure what they put here. That's what they have here. Alright, using a suitable diagram, describe the steps of adding a new node to a link using a suitable diagram. Alright, 3 marks. In another paper, this thing was 6 marks, you know. That's the problem is. Alright, so step 1 is create new node. After you create the new node, you're going to point that up. You're going to point the new node to the previous field, and then third, you're going to point the top to a new node, and that basically is going to look something like this. Is the link list I would have had. You put 10 and then 20, and then there. You're going to create a new node inside here, inside 35 to point to here, and then you had which was pointing there, and now point here. Pretty much. 3 marks. Alright, write the C code to declare an array named num sequence to store a sequence of integers from 0 to 20 inclusive, an array in num seq and 20. And 3 marks. You can store a sequence of numbers from 0 to 20 inclusive. Oh, nope. It'll be 21 locations, because if you start from 0 to 19, it'll be 0 to 21 is 20 locations. I mean 0 to 20 is 9. 0 to 19 is 20. 20 will be 21. Take the array location for the integer 19. Ooh, this question is a tricky one, but we could catch it. The location of integer 19 will be num equal 19. That'll be the array. The array location 19. Array location for, you want to store the numbers 0 to 20 inclusive. That's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this is actually 20 values here. This is location 0, location 1, location 2, location 3. Yeah, I'm confused now. Hold on. Let me not take this for granted because it should be 21. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, right? So those are the numbers that we want to store. We create an array and we're going to start at 0. This will be 0, location 0, and this is location 20. Did it not store all the integers from 0 to 20 inclusive? So it's 20. The array size is no, but you can't put the array size. When you create the array, you're creating the array, and when you put 20, that means there are 20 locations, but 0 to 20 is 21 spaces. Okay, that's why it's 21. Okay, yeah. Understand? Yeah. Because when you do it in C, you're telling the computer create 21 spaces, but we starting counting from here 1 to 20. This is what we will count to, but the computer had to count from here, so we had to include that, so it's 21. Alright, and then the location of integer 19 will be at location 19 because it'll be 20. Okay. Alright, crisis averted. That's correct this time. Write a snippet of C code to call a binary search function. Binary search given the parameters. Ah boy. Let's see how you write your binary search. Wait, that's what a snippet of code. Oh, we had to call the binary search. Okay, I thought we had to write the whole binary search. Alright, that's not that bad. The function binary search will return the location of the key in num sequence if it is found, otherwise it returns the value -1. Okay, in location is equal to binary search. Binary search, open brackets, given the parameters num sequence, num seq, open brackets, close bracket. No, actually know how to put open brackets, close brackets because we're gonna array, so let's kind of send it. Search key low and high, and it will return the location. Can't say anything other than that. So we declare the integer for the location, and yeah. 4 marks for that. Look at space. Like what? You see, those are the kind of things that'll chain up people and be like, wow, that's a lot of space there. I probably have to write out the whole binary search, and then that's really what I want to do for that. I trust you will not cause. State the required condition for binary search in an array, which will be must be sorted. Yeah. I determine the number of comparisons that are needed to search the num sequence array and to find the value 20 using a linear search. State one reason for your answer, a reason for determining the number of comparisons. So you literally tell them, determine the number of comparisons. State a reason. Why? Or what is the reason? Alright, to find the value 20, it will take a 21 comparison. because we clearly had to go from 0 up. Because we're going from 0 all the way up, this will count as 1, 2, 3, 4, 5, 21 comparisons to reach number 10. Take one reason for your answer. The reason it will take 21 comparisons is because every location has to be checked. Aha! Right. Determine the number of comparisons on you to search in sequence array to find values in a binary set. Show all region. I'm going to have to draw out the whole array or maybe not. Maybe I did this already. Not to have lined up. Alright, so showing all regions because we want to do that. And what we want to do, we want to flip this in half time. Alright, so what are we doing? We are saying because there are 21, that means 11 will be in the middle. And no, 11, 10 will be in the middle. 10 will be in the middle. Middle will become 10 will be the middle. And we will knock off that's one comparison. And once we've knocked off this part here, our high will go up to 11. No, we lost it. The middle here will be 5, and we are round down because we figured out that we always have to round down from all of our exponents. Round down or round up here, round down. Right. So the middle will end up being here, and then we're going to knock off this bottom piece here. So that will be 2 comparisons. The middle will end up becoming 18 middle, and that will be a 3 comparison here. We cut off that, the middle will become 19 down here. So all like that, and that'll be 4 comparisons, and then the middle will become 20 or 5 comparisons before I find them. Yeah, 5 comparisons. Use C code to create a function named swap, which takes an array and location. The purpose of the function is to interchange the contents of the 2 locations of the array. Alright, so function is swap, takes an array and 2 array locations. The array would be RR, the array location would be A and B. Interchange the contents of the 2 locations. Alright, so we have to create a variable called temp. Temp will be supposed to be int AR. Alright, int temp, and then we want to say temp is equal to ARR location A, ARR A is equal to ARR B, and ARR B is equal to 10. Alright, we good there. Describe our selection sort can be used to sort an array of 10 integers from smallest to largest. Describe selection sort. Alright, the first, how much marks this is? 3 marks? Wow. The first value of the array is stored in a variable. That value is compared with every other variable after 2 if there is one smaller. If there is a smaller value, it is and the possible index upward. Yeah, 3 marks. That's with it. Alright, based on the information below and functions get smallest and swap. We write a function called get smallest. We're just assuming that we just have that. Use C code to create a function called selection sort that performs a selection sort on an array with known boundaries low and high. Oh, they gave us what get smallest is already. Returns the location of low and high. Alright, void selection sort int ARR in low and high. And from there, the first thing you have to do is your goal is to go through the whole array and find the smallest value. But you have to send the low and the high, the lowest and the highest integer. This one tricky, this one is tricky. Alright, so how we will solve this is we're trying to go through the whole array. So we're going to say for, I had to declare I at a selection, so it does have an I and a J. But we kind of take the, by getting the smallest, what they're doing is taking away the J and the J, trying to get smaller. Okay, so for I is equal to small, equal to low, sorry, because they gave us low and high. So basically, so they're telling us what to start from. I is equal to low, I less than high. I'll be the highest value in the array. Right, okay, good. So the selection sort, we know what the low is, we know what the high is, because the goal of the selection sort will go from low and work its way up one at a time, I plus plus. What we want to do, the function called get smallest is going to go through the whole array and find the smallest number for us. So that means we should catch it in our value. So int high and int small is equal to 0. So then I should say small is equal to get smallest and send the array and low and high. So that, this one going to simulate the second loop for me, which is going to check through all the locations and check to see what is the location of the no, I'm not sending low and high. I can't send low and high. I have to send the location of I. Because if I send the location of low, that means it will always be at location 1. But if I send the location of I, this for loop here will determine what I'm comparing to for the selection. So the small is equal to get smallest ARR, I and high. Yep, that makes sense. So you will get the smallest value from the range that I set, because in our selection, so the range always moves up each time. Once I get back that small, if the small is, do I swap? If it's a if, then do I swap? Let's say I get back the smallest value, but suppose the value is already small. And let's say I have 2, 3, 9, X, and that basically falling get smallest. So go and find the smallest value out of all of these here, and be like, well, the smallest value. Oh, I don't want to swap with the 2, because the 2 is already in the smallest value, in the smallest possible value. Yeah. So I'll only swap if small is less than the current I, which is ARRI, which is the start value. Then I do the swap, which is I just do the swap of the swap ENB. Then I will swap ARR. I'll swap location. I'll swap any value that's in any array, ARR, and the 2 location. So I swap in I or small return in the location, and very small. Get smallest returns the location here. So I swap in the 2 locations. Yeah, it's another video. And that's it. Yeah, that's plenty for 3 marks. So that's plenty for 3. And I'm watching the answer that they have in the report. They didn't put in that if. Why would they not put in that? Oh, you don't need to put in that if, because get smallest is going to do the check-in for you. But then how will you know when to swap? No, if get smallest get okay, no, you could put in that. Yeah, so the swap will only take place if the value that I get back, if ARR small, right? So if ARR location small is less than ARRI, then you swap. Yeah, so if the index that had the smallest value is smaller than more value, then you swap. Okay. Plenty work for 3 marks, but I really feeling that question. Did you do that or something like that? Or you're totally captivated by it? So like, oh.
The second one.
Good thing is it's only 3 marks, so you wouldn't die. You would not die. It's a modified selection, so they had to understand how the selection sorts. I really like how it was done, but there must be something to challenge you. Consider the following array with 5 integers. Use a bubble sort to show the contents of the array. Wow, they went real hard in this paper for little marks, but there's small marks all over the place. Alright, consider the following array with 5 integers. Use a bubble sort to show the contents of the array at the end of the first pass and second pass. Alright, numbers do I have? 30, 50, 40, 60, and 20. Alright, first pass. Bubble, 30, 50, not going to switch. 30, 40 will change. So 30, 40, 50, 60, 20. I'll be end of the first pass. And then the second pass now. 30 will stay the same, 40 will stay the same, 50 will stay the same, 60 and 20 will switch to 20. Will end up pushing. Right, that'll be second pass. Oh no, at the end of the first pass, I would have swapped the 60 and the 20 also. At the end of the first pass, the 20 would have ended up getting swapped with the 60 because it had to reach to the end. And then on the second pass, the 20 and the 50 would end up switching. Right, cool. Yeah, that's it. This was not a nice module 1. On a scale of 1 to 10 of module 1s that are painful, one ranks fairly high up there, fairly high. The first few questions, I was like, alright, cool, let me just answer these questions, simple.